All right, as we move in the next technology here in Chapter 1, the book talks about a radio or wireless transmission, if you will. With wireless transmission, the first things to occur were radio, then we moved into television, satellite, that sort of thing. So they're starting off with radio for us. Late 1800s, we have Marconi developing the first long-distance wireless telegraph. Again, instead of using a wire to connect town to town, like, hey, there's got to be a way I can send this through the air. So Marconi develops what's called a spark gap transmitter, and with that, able to modulate basically pulses of electricity to send through the air the dots and the dashes kind of thing. And here's a model of, or here's a sample of what his spark gap transmitter, the first wireless radio, looked like. At roughly the same time and shortly afterward, the development of this was aided by Nikola Tesla. Nikola Tesla is a name you should know because our form of electricity that we use out of our outlets, electric outlets, alternating current, was a development by Nikola Tesla. Here he is here. And he was developing the same kind of idea, but he developed even further into the first RC boat, first radio-controlled device, a boat. And he thought it was going to take off more than it did, but the interest on it was kind of low at the time, which seems boggling. And yes, I'm a nerd. When I was up at Niagara Falls, there's a statue of him in Niagara Falls, so I had to have my picture taken with it. At Niagara Falls, there is a statue of him because he helped with developing the first hydroelectric power generating facility at Niagara Falls. So that's why there's a statue up there. Not long after that, the first vacuum tube, Audion tube, was developed by Lee DeForest, and this was turned the wireless telegraph into what we would call radio in the early 1900s. This was able to amplify small electrical signals, kind of like the beginning of a little amplifier. So if I have a very faint signal in the air, something like this can help amplify that I can actually hear it. Early 1900s then, this is just a little fun fact, listeners were used to hearing Morse code over radio, was astounded to hear music and voice, and we have an individual in New York City that was broadcasting the New York City yacht races over radio. That's huge when you were used to hearing just dot, 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 dot across the radio. Now you actually hear a voice. So in the early 1900s, the development of ship-to-ship and ship-to-shore communications was occurring. And as you look at that timing, you're looking at roughly World War I timing, figuring all of this out and being able to transmit from ship-to-ship and ship-to-land communications instead of having to worry about telegraphs and that sort of thing. 1919 RCA form, Radio Corporation America. Some of you recognize that, so I threw that in there for fun. 1920s, Detroit Police Department. First land-based communication system. For this one, what they did was they were actually broadcasting out, instead of police officers stopping and using call boxes to call in and go, hey, is there anything I need to be aware of? They're trying to develop a radio-based system that the police officers could get information. In that case, though, it was actually just kind of broadcasting out, and the police department vehicles, the police cars, would receive it, but they couldn't send anything back. The good side was it was better communication. They didn't have to stop and use call boxes to get information. It was being broadcast out. The bad side was they had lots of problem with failed and delicate equipment and pieces at that time. So not quite sturdy enough to be used in cars yet. 1920 and 1928, we have at Purdue University and Robert Batts. They developed a type of radio, super heterodyne radio. Now we have a better receiver for police vehicles. Now in 1934, 200 radio-equipped city police departments were communicating with nearly 500 roving vehicles. So now much better radio. So the development of radio technologies between, police base station and radio police cars was working. Now much better communication between the two. Now radio was becoming much more commonplace. So I threw this in to remind you that, in these days, you'd have a radio in your house, and that would be like a piece of furniture, almost like a TV, prominent in your room. And there was actually magazines that you could buy with what was being broadcast on what day at what time, so you could tune in to hear your favorite radio program, radio broadcast. 1937, FCC steps in and allocates 19 radio channels to the existing 11 radio channels that were made available for police use. So now, in our electromagnetic spectrum, as I look at the area where there's radio waves, this is now starting to get controlled, regulated, divided up, that different radio stations and things can be organized on here and controlled. At this point, we're looking at mostly AM radio technology, amplitude modulation. The drawback to that is the strength of the transmitted signal diminishes according to the square of the distance, so it drops off rather quickly. With 1935, we had Edwin Armstrong develops his FM radio using frequency modulation. This eliminated some of the noise problems, static, that AM had, and allowed lower power transmitter requirements. I didn't need as much power to transmit, a little bit more efficiently. So the development of FM comes along. And Edwin Armstrong demonstrates his FM radio in 1935. So World War II then becomes the ideal proving grounds for testing FM. At the time AM was being used by the Axis, was easily jammed. FM being used by the Allies is almost unaffected by AM jamming techniques. So the FM radio has been attributed, or is attributed to one of the pieces attributed to the success of the Allies during World War II. All right, when we come back in the next podcast, we'll start talking television.